Derivatives, communication and thinking question. When taking higher order derivatives of a polynomial function, how many can you take before the derivative starts repeating? What is the value of the derivative when this occurs? Well, this is a very interesting question, and let's take an example. Let us say f of x equals to a times x to the power of n. Then what is f dash of x? F dash of x is n times a x to the power of n minus 1. And what is the next derivative? Next derivative will be, again, x is the only variable, so it will be n times n minus 1 times a x to the power of n minus 2. So what do we see here? We see that the derivative's power starts decreasing by 1. Ultimately, if the degree is n, we'll get n minus n, which is 0. Do you see? So first derivative is n minus 1, second derivative is n minus 2, and so if we do it n times, right, then it will be n times n minus 1 like this, and here ultimately will be n times, that means a x to the power of n minus n. Do you see that? So last will be like 1. Do you see that number reduces? So it's kind of a series. And here n minus n is what you will get. Now what is n minus n? N minus n equals to 0. Do you see that? That means x to the power of 0, which is kind of 1. So at the end, you will get a constant. And after that, if you get 1, then what is the derivative of 1? The derivative of 1 is 0. Do you see? So at this stage, you get a constant, x to the power of. So we can take one example here. If we have x cube as our function, let us say y equals to x cube, then y dash is equals to 3x squared, and y2 dash double dash, second derivative, will be 2 times 3, that is 6 into x. Now this is x to the power of 1. Do you understand? And next will be y triple dash, and that is equals to 1 times 2 times 3 x to the power of 0, right? X to the power of 0. Do you see that? What is x to the power of 0? It is just 1, right? Constant. So it is just the number 1, 2, 3. Now if I do the next derivative, which is my fourth derivative, let me write 4 here. In that case, since this is a number, this is actually 1 times 2 times 3, which is 6. So what is the derivative of 6? It is 0. Do you see that? So if the degree is n, then we can find n plus 1 derivatives. Do you see that? So the answer for the first one is, when taking higher order derivatives of a polynomial function, how many can you take before the derivative starts repeating? And after this, it starts repeating as zeros. Do you understand? So the fourth derivative, and thereafter it becomes 0, right? So either way, we can say we can take the third derivative. How many can you take before the derivative starts repeating? Now after third, it becomes 0, and now it becomes 0 thereafter, right? Because the derivative of 0 will be 0. There's no function left here, right? It is a 0 function. So we can say we can take n derivatives when we get a constant, and after that, whatever derivative you take, you'll get 0. Do you understand? So we can say we can take n derivatives, and after that, what is the value of the derivative when this occurs? The value of the derivative is 0. So either we can answer it in two different ways. How many can you take before the derivative starts repeating? So at this stage, we are fine. After that, we get 0, and after that, we get 0 again. So we can say, if we are asking what is the derivative, then we should say this is, nth derivative gives a constant, right? And n plus 1 leads to 0, and after that it repeats. So what we should answer here is n plus 1 derivatives, correct? So our answer is, we can take n plus 1 derivatives. correct? So if we have a constant, let us say function is y equals to 5, where actually speaking degree is 0 for x. It is a constant function. We can still take a derivative of this, right? So that means we can take one more derivative than this, right? So y dash is equals to 0, and thereafter we are going to get zeros. So we can take n plus 1 derivatives for this function. So n plus 1 is our answer. And what value of the derivative when this occurs? The value of derivative is 0 when this occurs, right? So that is a very interesting question. Thank you.